Hello and welcome to Notebook. We are back with a new video lesson on a fundamental chapter, motion, from your syllabus. But before that, meet Neeti and her brother Mohan. Look, don't they seem busy? They are getting ready for school and they have a test today. They picked up their school bags and left their house. Mohan is excited as he will be going to school on his brand new sports bike that his father had gifted him on his birthday. Neeti, on the other hand, decides to walk to school as she had to buy new pens for her test. Mohan left for school directly, whereas Neeti made a detour to the market to buy pens. She then started walking towards her school. So, who do you think reached school first? Of course, Mohan. But can you tell me why? Yes, because Mohan took the shortest possible route to school, whereas Neeti made a detour to the market. And what else? We also have to consider the fact that Mohan was riding a bicycle, whereas Neeti was walking. Thus, Mohan's speed was much greater than Neeti's. Now that you're thinking about it, let me introduce this chapter to you. See, the name of the chapter says motion. What do we mean by it? In the simplest way, we can say that motion means movement. We said movement, right? Let us look at an example. Look at this ball. Note the stopwatch as well. It moves from point A to point B, and on doing so, it took 4 seconds. So we can say that a ball, when moving from point A to point B, changes its position with time. This is known as motion. Remember Neeti and Mohan? They did the same thing. They moved from their house to school, that is, they changed their position with time. So we can say that we have performed motion while going to school. Okay, let's take another look at this. The ball is at A initially and does not move with the passage of time. Now, can you tell me what happened here? The body is in a state of rest as it did not change its position with time. In the example that we have in hand here, we see that the ball's position changes with respect to point A. Thus, we can say that in order to classify objects at rest or in motion, we choose some convenient fixed point in the surroundings of the object. And such a fixed point is known as the reference point or origin. Thus, in this very case, we can say that A is the reference point or the origin. But it must be kept in mind that the states of rest and motion are completely relative. What do we mean by this? Very simply, when you are inside a bus and look outside the window, the surroundings seem to be moving while you stay fixed on your seat. However, for a shopkeeper on the same route, you appear to be in motion along with the bus while he stays fixed in his shop. Okay, now that we have a pretty detailed idea about the fundamentals of motion, try recalling the different types of motion that we have already learned in our previous class. There are mainly 3 kinds of motion, namely linear motion, circular or rotational motion, and lastly vibratory motion. We will talk about each one by one in brief. Linear motion means motion in a straight line. The example that we took earlier was an example of linear motion as the object moves from point A to point B along a straight line. Next is circular motion. It is the motion of a body along the circumference of a circle, like the motion of the Earth around the Sun or the motion of the Moon around the Earth. Okay, a special type of it is rotational motion. Do you know why? Because it is the motion of a body around a fixed axis passing through it. Look at this motion of a spinning top. It is rotating around an invisible axis known as the axis of rotation. Okay, last one, vibratory motion. We can define it in 2 ways. We can say motion of a body that repeats itself at regular time intervals, or to and fro motion of a body about some fixed point. Look at this child swinging. He takes exactly 4 seconds to complete a round, and he does this repeatedly. Is this an example of vibratory motion? Yes. Look at this car moving. Look at its wheels. What type of motion do you think they represent. You may say that this car moves in a straight line, thus it undergoes linear motion, and I will say you are correct. But let's take a closer look at the wheels. They are undergoing rotational motion as well. Thus, we saw that an object can undergo more than one kind of motion at the same time. It was great fun learning about the fundamentals of motion. Now, we will try to understand what scalar and vector quantities are. Scalar quantity is a physical quantity which is completely represented by its magnitude only. Such a quantity has only magnitude and no direction. On the other hand, a vector quantity can be represented by both magnitude and direction. Examples of scalar quantities include distance, area, volume, mass, etc. Examples of vector quantities include acceleration, displacement, force, weight, etc. The last and the final topic of this video are distance and displacement. Look at this park. Each side is of length 1 kilometer. Now tell me, if Anita starts walking along the sides of it from point A to reach point B, how much distance did she cover? Think. You are right, 3 kilometers as you can see. But think about it for once. What if instead of taking this path, she took a right and reached point B? That is the shortest possible route for reaching point B from point A, as she will just have to walk 1 kilometer. Just to make it clearer as to why we discussed this example, try to understand that we calculated distance in the first place and displacement in the second. A quick definition says that distance is the actual length of the path between the starting or reference point and the final position of a moving object in a given time. And displacement is the shortest possible distance between the initial and the final positions of a moving body in a specified direction. Remember, in the beginning of this chapter, we saw Neeti and Mohan going to school. Now do you understand that the path covered by Neeti is calculated as the distance and that by Mohan is calculated as the displacement? Well, great then. Before we wrap up this chapter, let us quickly learn the major points of difference between distance and displacement. Distance is the actual path covered by a moving body, irrespective of its direction. But displacement is the shortest possible path between the initial and final positions of a moving body in a particular direction. Distance is a scalar quantity, whereas displacement is a vector quantity. Distance is always positive, but displacement can be positive, negative, or zero. Distance is always greater than or equal to the displacement, but displacement is always either less than or equal to the distance. That makes it even easier to understand and remember, right? So friends, we are done with our first session for this chapter. If you want to know more about other interesting topics like speed and acceleration, watch our other videos on this chapter. I hope this was a great session for you. See you the next time with another part of this video. Until then, happy learning and goodbye.